Here I'm gonna cover photoelectric effect. This problem is taken from OpenStack 6.2 problem 75. It says find the maximum velocity of photoelectrons ejected by an 80 nanometer radiation if the work function of photoelectrode is 4.73 electron volts. So this is the diagram that I draw to illustrate the situation, where these two are the electrodes, and then there's a light source, a radiation, shining 80 nm radiation, and it creates the photoelectric effect. So the problem is asking us to find maximum velocity of the photoelectrons, given that the wavelength of the photons is 80 nm, and the work function, I denoted it as C naught. I should actually say this is work function. Work function would be 4.73 electron volts. So the electron of the energy of the photons is equals to hc over lambda photons. So I just plug in the values of hc and the values of the lambda photons, and I get the 15.5 electron volts. That means that for this energy source, it carries the energy of 15.5 electron volts. And then this equation comes from the energy input equals energy output. So with the 15.5 electron volts, 4.73 electron volt would be absorbed by the metal, which is the work function, and then the remaining energy would go to the energy of the photoelectrons. So I have the energy of the photoelectrons here. I converted it to joules because all the energy of the photoelectrons would be converted into kinetic energy, which is here. This is like the kinetic energy equation, K equals to 1/2 mv squared. So I have the v, the speed, and I basically complete the problem here with here. But I want to extend a little bit more by discussing what photoelectric effect is about. So the first thing is, what if we increase the intensity of the light source? Then what would happen to the photoelectric effect? The current would increase in this case. And this is like the typical graph of the photoelectric effect. The current increase means that it would go here and then share the same starting point. So number 2 is when the wavelength decrease, then there would be an increase in the voltage. So I'm assuming that the photoelectric effect, it has a current inside, and it is within this range. So if I decrease the wavelength, I eventually would reach to one wavelength. If I decrease the wavelength, then the voltage would increase. But if I increase the wavelength, which is decreasing the frequency, then I'll reach to a frequency that will stop the current, as the energy of the photons would be less than the work function, and that is called the stopping frequency. And the third thing is that if we invert the battery with negative and positive sign here, then what would happen is that the potential difference would be from positive here to negative here. So if I switch from here to here, there would be a driving force pulling the electron backwards, and then when it reaches to the stopping potential, that means even the maximum velocity of the photoelectron could not reach to the other metal plate, and that would be the stopping potential. So that is the photoelectric effect.